Good morning. This is assignment one for CIS 496K, fall 2024. And the first question required me to get Peppers and Mantle image from a link we were provided. And we're supposed to display both the images using IMShow. And that is what I did here. So I'm using OpenCV to do my like showing and reading. So I load the images here, I read them, I normalize them to fit the 0 to 255 range, convert them to 8-bit if they aren't already, and then I show the images. So I'll just run this and then we can see the two images. So these are the two images. And I'll just stop this for now so that I can explain the other part of the code. So question two required me to load image one, swap. Then question B was swap the red and blue channel. So I load the image here, and then I swap the red and blue channel. So what I'm doing here is I'm using the classic technique of like, if I want to swap from one place to the other, I need a separate folder where I take something from here, I store it there, move something from here, store it there, and then move something from there back here. So in our OpenCV does not normally like it does not load your file in the RGB format that we know, but it actually loads it in the BGR format. So what I've done here is I I take the I take the BGR. So I take the red part and I store it here, swapped image red. And then I take the blue part of the image, I replace it where the red part was, and then I take where the blue part was and replace it with the red. So I've exchanged the colors. And then this is using the pre-built function. And then 2C required me uh, to only show the green channel. So the green channel is like I'm setting the blue channel and the red channel to 0. So only the green channel shows. 2D requires me to show only the red channel. So I set the blue and the green channel to 0. It only shows the red channel. And then 2E requires me to convert it to grayscale. So that is what I do here. And if I run this, these are two images, and then this is using like swapping the red and blue parts, only the green, only the red, and then gray, like grayscale. And then question three required me to take 100 and 100 pixel located in center of image one and insert it into center of image two. So that's what I did here. These are all the calculations for like finding where the center of image one is, and then these are the calculations for finding where the center of image two is. And then here, this is where I'm setting the image, and then I can run this script again. And notice how like this nose here will come somewhere here. So I'll show you in a bit. So let's skip this. And there we go. The nose has come here in between. And then question four required me to find the minimum and maximum value of image G. What is the mean standard deviation? How do I compute this? And then you want me to subtract the mean from the pixels, divide by standard deviation, and multiply by 10. So that is what is happening here. And then for C was shift image by left by 2 pixels. And then I'll just run this script so that we can walk through them. So right here. So let's start from here. The minimum is 0, maximum is 247. Mean pixel value is that. And I use NumPy to compute this. And the next part was shift, subtract the mean from all pixels and then divide with standard deviation. And it is this one. So you basically like normalize it like that. And then question C was to shift image G by 2 pixels. So if you look here on the right, there's a black line because the pixels that were here have been moved to the right. I mean, moved to the left. And basically the two columns of 2 pixels here have like basically been eliminated. And then 4D was to subtract the version of image G from the original. So if we go here, so I've subtracted that from the original. And subtract the shifted version of image G from the original. So this is the original image, and then I subtracted the shifted version of it from it. And then the next part was flip image horizontally. So that's what I'm doing here. Now it's flipped. This is how you can reverse the columns, because the way that the NumPy array for images are set up, it's rows, columns, and then if I put an extra something here and something here, like 0 or 1, that is the channel. And then the last part was change the intensities from the highest become the lowest and the lowest become the highest. So that's happening here, the inverted image. So, and then the last part was add Gaussian noise to it. And what the question was, what standard deviation did I use? So this is my way of adding noise. So I have a function and I'm using a standard deviation of 100. And this is the output. So I picked a standard deviation of 100 so that I can actually see the noise like clearly. And you can see the picture on the right is a lot more noisy than the picture on the left. And through this assignment, I learned a lot about the like different ways of image processing and manipulating images. Thank you.